So it's a set that includes irrational numbers, rational, I don't know how people write irrational numbers. It includes the integers though. It includes natural numbers. It includes, I think, 4 there. So all the algebraic operation, sorry, the real number system and the real number set is closed under all the algebraic operators. So that's division and so on and so forth. So yeah. Now, so we have this idea of something called a Cartesian product. A Cartesian product is just mathematicians' ways. Give me a second. So a Cartesian product is just a fancy way mathematicians say dot product. So if I have a set A and is equal to A comma B comma C, we have that A cross A, which is equal to A squared, is a Cartesian product. So A squared is equal to A, B, C, A, B, C, right? So A squared is okay, so this is, I'm going to start using some terminologies here. A squared is called a two-tuple pair. So any combination of sets forms what we call an n-tuple pair, In this case, the index, the index represents the n there. So this is a two-tuple pair. So if I do this, it's dot product. So it'll be a set, and let's call A squared equals C or something. So C is equal to, so it's an ordered pair. So I have AA, AB. What do I mean by two-tuple pairs? Because we have 2 elements in a pair in these brackets. So AB, AC, that. So you have BA, BB. I hope you see the idea. I could have just done 2 elements in the set. It's still not. So you have the same thing here. So you have BA, BB, and BC. And you have CA, CB, so on and so forth. So that's the case. I hope you get the idea though. So actually we have another number system of numbers that's actually greater than the real numbers. It's called the complex numbers. So the complex numbers, we have subsets in which the subsets of the complex number will include the real numbers. I'm just thinking of something. Yeah, so it include the real numbers and the other subset. Anyways, so yeah. So in two dimensions, our Cartesian coordinate system will be a real number squared, the Cartesian product of the real numbers. The reason why is because we have 2 dimensions, y and x. We need a tuple pair. So we're going to define 2 sets here. We're going to call this a set C. So let me start. The set A is equal to x and y such that x is a member of the real number, y is a member of the real number system as well, and x comma y so x and y is greater than 0. I have to write this more differently, so it has to be something like this. X comma y is a member of the real number system squared. So all this defined, this set will be this coordinate system. So it'll be all the numbers here and all the numbers here, disregarding all the numbers here. That's what this set will be. Let me give you a feeling of what R squared is gonna look like. Wait, let me go, because R squared is too dense for me to do, because if I have to do 0, I have to go do 0.0. It's too dense for me to do, I can't do it. So I'm going to be using natural numbers, for example. Squared is equal to, let's say, let's just say it's, because it's going to be something like this: 1, 1, 1, 2, 1, 3, 1, 4, 2, infinity, and 2, 1, 2, 2, 3 to infinity, and so on and so forth. So it's very infinite. So just imagine how infinitely large the natural number system is. Then you compare that to the real number system. It's kind of, it's very dense. And so remember I told you that so complex numbers are higher than real numbers. So you have some other numbers like what are they called? Quaternions, octonions. It's like crazy. It's crazy stuff. Anyways, let's define a set C. I keep using C. Let me say lambda this time. Lambda to be a set x, y, that's part of the real number system, the real number set, the Cartesian product of the real number set, such that x is a member of the real numbers, y as a member of the real numbers, x and y less than 0. Less than 0. So let me give you a quick feeling of what this is. First of all, this is the Cartesian coordinate system for A. So this is y, this is x, and this is the Cartesian coordinate system for lambda. So look at the both of them. So these two. So if I do A union lambda is going to be the whole two-dimensional Cartesian coordinate system. Yeah. So this will be A union, so it's just everything joined together. That'll be the whole Cartesian coordinate system. So I told you 1/3 of this video is going to be relevant. This is just for the very much more mathematically minded people. I don't think this is actually, I guess it's actually useful actually. Perhaps when in the more advanced stuff that I probably don't know, they actually use this a lot. So this is how they do their definitions of Cartesian coordinate systems. Anyways, yeah, so thank you. This is y, this is negative y, x, negative x. Also note that if you rotate a coordinate system and you see, well, any rotated coordinate system, it depends. So if we're dealing with Euclidean, Cartesian coordinates, if you rotate it though, and you say it's a rotated coordinate system, it still has the same, it will just change all this x and y's to x primes and y primes, and it's more or less the same thing. It's not even more or less, it's exactly the same thing. So that's the mathematical basis of, well, it's not abstract, because these days, when people use the word abstract, people tend to think about difficult. It's not. It's just, the mathematical basis of a Cartesian coordinate system. So, well, that's it. Thank you for watching today's video. this is literally, we've already done half of coordinate geometry. So if I can do the other half, maybe the next video I'll talk about I'll just like 2 or 3 examples and then talk about perpendicular bisectors, and that'll be all. And sorry, forms of equation of a line, forms of writing the equation of a line. I think 4 or 5 or 6 forms. Yeah. So you have slope-intercept form, you have the general form, and you have the x-intercept form, you have y-intercept form. Yeah, I think it's 4. Yeah. So yeah, that's all about that. This is just a mathematical basis for coordinate system. Thank you very much for watching today's video. Like, share, subscribe, and tell other people about it. Thanks.